There we go. All right. Oops. There we go. I'll make sure my clicker works. All right. So, clustering digital ink content to assist with the grading of student work. To start off with, I'll give some context and background information. Tablet PCs are specifically designed for the Windows operating system. There's other types of tablets, but a tablet PC runs on Windows. In many schools across the nation, Speed School being one of them, have one-to-one deployments where the instructor and every single student in the room, as the lecture is going on, has a computer in their hands. Now, that's the hardware, but obviously having hardware is just the first part of the story. What really needs to happen is the software makes the magic happen in the classroom. And the software that's used specifically is classroom learning software, or CLSs for short. They come in lots of shapes and sizes and varieties. Dino is a proprietary implementation of a classroom learning system. And Classroom Presenter is an open source version of a classroom learning software, but there's lots of others. The whole point and the whole goal of having classroom learning systems being used is for active learning, and the goal is to increase student learning outcomes. There are many organizations that have deployed this, run experimental tests. You put tablets in one group of students' hand, you don't have other students with tablets, and does that increase the learning outcomes? And the majority of the research shows that yes, it does. There are difficulties, but it's a good thing. I am not focusing on that aspect of the tablet PCs in the classroom. I'm focusing on something that I don't believe has received a lot of attention, and that is the grading process. So this system was designed based around atoms, moving around paper. This is as old as education. Instructor creates a question, gives it to a student, the student answers the question, the instructor collects all the paper back up, puts marks on all the pages, gives student feedback, and then hands them all back out. So when we decided to move into the digital realm, what always happens is you copy the existing workflows. This system that was designed around atoms was simply copied into cyberspace in the digital world, and this whole system was reinvented with bits. But part of this is very inefficient when it comes to bits, and that is the grading process. When you have atoms and you have physical pieces of paper, you can't make infinite copies at no cost. You can't just tap a stack of papers and make them go into alphabetical order. When it's in bits, you can, with one button, put everything in alphabetical order, and you can make unlimited copies at zero cost. So the part of the workflow that I'm focusing on is the grading. Everything else is the same. Distributing work, collecting student work, and even returning student work is all the same. But having the ability to group similar student answers. A student might have multiple answers on the same page. Can you collect all of those similar answers? On paper, that's not possible, because not every student answered every single answer the same way. So you can make unlimited copies. And also generating a grading report, putting something in alphabetical order and getting the grade report out. There's a lot of opportunities for automation. So the classroom learning system that I selected was Dino. One of the most obvious reasons I chose this was the University of Louisville uses Dino, so I have a client right next door. So the software had direct benefit for the use. There's also some reasons that Dino made itself more attractive than other classroom learning systems. One of the reasons is Dino uses Active Directory for authentication. So when you collect works from students, it includes their full name and their username. So the panels that are collected are in some way authenticated, while other systems don't have that type of assurances. Also, Dino has this thing called an answer box. And an answer box is just a region of the panel that the student puts the answer in. And I'll come back to that in a little bit and explain those a little more. So some background information on how I came to this point. Some of you in the room know this, but I was approached in the fall of 2008 in the Engineering 101 class. The calculus class wanted to move their in-class problems from paper to digital. They were using tablet PCs in the classroom for other reasons, but the in-class problem was a legacy artifact that hadn't been moved digital. So I was just basically told, hey, we want this on the computer, do it. So luckily, and I managed to come up with a system that worked. Fortunately, I was a computer programmer and realized that doing this by hand was absolutely impossible. I'm rounding up, but approximately 900 panels collected a week even if they're on the computer, sorting through the names and generating a report by hand, even on a computer, is a ridiculous amount of time. So I created a library that let me read in Dino files. Even though it was a proprietary software, I could read in the contents. And I created my first piece of software that was based off of Dino called DPX Manager. And this is grading student work for attempt. I'm not grading for accuracy here. You're not really going down into the details of the student work. It's did they make an attempt, yes or no. If you need to dive in, you can. But what this can do is it can generate a grading report that the graders can use in a matter of seconds. What used to take hours of manual alphabetizing on paper, and what even took hours of semi-manual alphabetizing on the computer, this takes down 2 seconds. In some cases for longer reports, minutes. DPX Grader was my next attempt at improving workflows, and that was take a group of Dino panels that the instructor had already graded inside of Dino. How do you get those grades back out into your gradebook, such as Blackboard? This takes a handwritten grade in the corner of a panel, performs handwriting recognition on it, and spits it out into a file that can be manipulated and put into a gradebook. But that wasn't enough. I wanted to go a little farther, so I came up with DPX Answers, and this is focusing on the student work, the student's answer, the handwritten student answer. So I said I'd come back to answer boxes. So this is what I'm calling the anatomy of a Dino panel. Dino panels are very flexible. You can type, you can ink, you can draw shapes, you can do lots of things with them. But this is the structure that I'm assuming is being used, which is fairly reasonable. The instructor places a question, either typed or handwritten, on the panel, and then they place answer boxes on the panel where the student is going to handwrite their answer. While the student could type their answer, I'm ignoring those. Those are the trivial case. If it's typed, and we already know what that is. I wanted a more challenging problem, and that would be handwritten